So the next section that we're going to talk about is going to be interval notation. All right, so that is section B in your book. All right, interval notation. And remember our essential questions that we are going to focus on. So now we're adding one more, but it's going to be how can we define the groups of objects, which is something that we've already wrote. And then we're also going to say, why are groups important? So why is it important that we are grouping these objects together? That's a new one that we're adding today. All right, so it's something that at the end, I want you guys to, throughout the video, I want you guys to think about, keep thinking about how we can define groups of objects, and also why are groups important. All right, so problems that you guys may have done before using inequalities, you may have gotten an answer where after you drew your inequality on the number line, -3, let's say, hold on, let's say this is here at 6, and our answer was, let me change the color, and our answer was in between here. All right, so this is something that you guys may have done before, where you're solving it, or you should have done before, you're solving an inequality, and you would have drew your answer out on the number line. All right, something that you should have learned is when you draw a closed circle, that tells us that the number is included with our answer. And when you draw an open circle like this, it means it's not included. So it means that we cannot include 6 as part of our solution, but we can include -3 because we have a closed circle. You guys may have written it like this before, where maybe, depending on how your teacher taught it, you might have learned it like this, where this is telling us we're going from -3 to 6. The square bracket tells us we're including it. The bracket, the regular parentheses, tells us that we're not including it. Or you may have just written it as -3, and then you could have said x is greater than or equal to -3 and less than 6. Or you may have written it like this as well. All right, but now we are going to go through where we want you to write it in set notation. All right. And this set notation allows for you or us to quickly describe sets of numbers using mathematical symbols only. All right, so it allows for us to describe what's going on using just mathematical symbols. So the way that we will write either one of these two answers, which these are the same thing, the way that we will now write this is we need to define that it's a set. Remember, our sets use our curly braces or use our brace. And then we're going to define, well, here we're using the variable x, whatever maybe you're using, whatever you're solving for, we're defining what it was that we were using. So we're saying the set, the way that this is being read is this says the set, and this is telling us what we're using, what variable maybe, so of all x's. All right, then the next symbol that we will use is this straight line here. And what that reads is it's telling us such that. All right, so this right here so far is saying the set of all x's such that, and then we can put what the answer is. So we can write exactly what we wrote here as well. -3 is less than or equal to x and less than 6. All right, so we can write this out as our set, and if we want to close our set off, then we'll just close it with another brace. All right, so that's one way that we can write this. Now, we have learned all the special number sets in our previous section. So what I mean by that is our natural or our counting numbers. We learn our integer numbers. We learn our rational numbers, and we learn our real numbers. Right? So if you do not write any of these symbols out, it is automatically understood that it is going to be part of a real number. So here, the way I wrote this, it is saying that this is automatically going to be part of real numbers. Another way that you can write this at the end is you can write it, and put this in a different color, you can put a comma, and then you can define what element or what set x is part of. So you can say x, and then we can define it here. So we're just going to say it's all part of real numbers. So if you don't put anything, it's automatically understood to be real numbers. But I want you guys to get in the habit of doing this right now because it's something you will need to do in the future. All right, so this, what I just wrote up, is our interval and set notation. right, so let's just read exactly what this is telling us. So let's go through. So this is saying, here is saying the set of all x's, such that, and then we can say what our solution is or what it is that we're looking at. So it's x is greater than or equal to -3 and less than 6. And then here we're defining which special number set that you are using. And then we will close off our set with another of the curly braces. All right, so now we're just going to go through 2 examples. And the examples that we're going to do now are going to be important as to why we need to write this last part out. All right, so for this part here, for A, we have that x is going from 1, 2, 3, 4, and 5. All right, so if we want to go ahead and write this into set notation, we would write the set of all x's such that, and then we're going to write the rule for what's happening with our x. So we're going from 1 to 5, and it's including both 1 and 5. So we will then say that x is greater than or equal to 1 and less than or equal to 5. Let me switch this to a pen, it's a little too thick. All right, now, the difference is here between this problem that we are doing and the one that we did before when I was describing it, is this is only including 1, 2, 3, 4, and 5. It's not including any of these numbers in between. It's not including any of these decimals or any of these fractions that might be between 1 and 2 or 4 and 5. So that's where it's really important that we define the set. Because remember, if we just close this brace, it's saying it's automatically a real number. So we will put a comma, and then we need to define what set that this element x is part of. So for this one, this can actually be part of 2 different sets. So either one would be correct. This is part of the natural numbers. So you can go ahead and you can write the natural number. And this is also part of, that natural number should look this way. And this is also part of the integer because both natural and integers both are dealing with the positives 1, 2, 3, 4, 5. So it doesn't really matter which one you put. I would accept both. I'm just going to go ahead and write natural, mainly because it's easier for me to draw that simple. All right, and then the one thing you have to make sure you do is you need to go ahead and close your brace. All right, so this is the answer to A. Now for B, I'll write it right underneath. Same thing here. Now since the line's going from -3 to 6, which this is exactly the problem that we just did before, but since it's going from -3 to 6, that's including every number in between. So we're going to write the set of all x's such that we know it's including that -3. So we'll say x is greater than or equal to -3, and it's less than 6. You could just write the brace here if you want, because since it's including all the numbers in between, when nothing's written, it's automatically understood that it's including all real numbers. But I want you guys, for right now, just to get in the habit of writing it out like this, where you put the comma and then you define what set your element is in. So it's in all reals. All right, now that is it for this video, and that is it for this section.